This project uses an Arduino to record the light level on a light dependent resistor using a voltage divider. We need to identify a suitable fixed resistor to use in the voltage divider. Too high or low and the light level changes we can measure will be reduced. The data will be recorded on an SD card and then imported into Excel to visualize the results. The first part of the circuit is the voltage divider. This is two resistors connected between positive and ground. The voltage of the center output, the orange wire, is dependent on the relative resistance of the two resistors. Therefore, as the resistance on the light dependent resistor changes, the voltage of the orange wire will change. This will be connected to an analog pin on the Arduino. Next, we have a series of switches which will allow us to differentiate between different tests. Here we have 4 of the switches wired up, giving 16 possible tests. The combination of switches forms a 4-digit binary value. Then we have an LED which will give some indication of the voltage levels being measured. Finally, a switch will control whether the Arduino is writing to the SD card or not. Turning to the Arduino code, we need to initialize the pins. Firstly, we have a couple of imports for the SD card code. The record switch is set to digital pin 2, the output LED set to digital pin 3, the 4 test selection switches are on pins 6 to 9, and the center output of the voltage divider is connected to analog pin 0. The setup routine of the Arduino begins by creating a serial connection. This is useful to have in the debugging stage, but doesn't really do much when the Arduino is not connected to a computer. Then, we initialize the pin mode for the digital pins. All of them are set to input, apart from the output LED. Next, we initialize the SD card. This is set to use digital pin 4, and so this one has been left free. Next is the loop routine. This begins by reading the switch. If it's high, we continue. The code then reads from the 4 switches to get the test number, multiplying each digit appropriately to get a number between 0 and 15. Next, we do an analog read to get the voltage from the voltage divider. We then concatenate the test number and the voltage value with a comma in the middle to form a string. We then do an analog write to the output LED. This uses pulse width modulation to set the brightness level and must be divided by 4, as analog read has 1024 values, while analog write has only 256. Finally, we open the log file up and, if successful, write in the new line of data, which is appended to the end of the file. Here we can see the completed circuit in action. When the switch is flipped, data starts recording. Placing a finger over the light dependent resistor reduces the light level, which should be visible within the recorded data. This is repeated several times for consistency. Once the data has been collected, it can be imported into Excel and graphed. This is a graph of the previously shown test. The dips at the start and the end of the data are from my arm blocking some of the light while reaching for the switch. The changes in light level caused by my finger over the light dependent resistor are immediately visible as some drops in the graph from around 300 to 100. We can also see that there is significant noise in the data, with the recorded value jumping up or down by around 25 points. Once a number of tests have been carried out with different resistance values and at different times of day, the data can be plotted. As we can see, there is a lot of noise in the data, which is making it more difficult to follow. Applying a 20-point moving average calculation will smooth this out. We can now see that during both the daytime and nighttime, significant changes in the light level can be detected. Nighttime values are always lower due to the brightness of daylight compared to a light bulb. We want a resistor value which gives a good spread of data at different times of day. Given that the possible readings are between 0 and 1023, the 10 kiloohm resistor uses the widest range of values and therefore is the one that I will use in future circuits.